Let's take a look at the shell. And the shell allows different options, allow you to work with the environment more efficiently. Controls commands, how you can pass in commands, parameters, options, wildcards, kind of a little bit of everything. Now the command line and their syntax. Command line, the line that contains a command, including any arguments. Syntax of it is command, then space, and then your argument 1, space, argument 2, up to however many arguments, and then you press return. Note some commands require no arguments, while others require a certain number. Try typing CP with no arguments. So if I come over here to Applications, Accessories, Terminal, and if I type ls, see I didn't have to put any arguments, but if I type CP, then it tells me, hey, you're missing a file operand. An option, an argument that modifies the effects of a command. ls-l creates a long listing. So you just type in ls by itself, does that. If I do ls and then -l, it gives us that. And ls-h, that's actually your default one for ls in this version of Linux. Human readable form for disk usage. Can combine them using ls-l-h or ls space -lh. And it doesn't have to be 2, you can have however many. I don't remember all the, let's see if I ls-l there's something more interesting to put on there. P and R. So ls-l-p-r. And it scrolled off. But recursive, that capital R is recursive. And it went through here and recursively went through different directories. And what else did I have? L is the long listing. P, what was P? P was the directories. So again, you can combine them together. Some options require arguments themselves. Example. I don't remember the exact syntax. I wonder if I got a C program. Doesn't look like it. I don't remember the exact syntax of a C program, but the GCC is a C compiler. And when you do -o like this, besides just pushing the -o, you have to. It has its own parameter, its own argument that goes with it. And trying to remember what these are. I think this is the source, and this is what you're going to compile it as, if I remember correctly. Now, I've already been using this. Many utilities allow you to use --help to get a screen full of useful information to get the command. I wouldn't say all of them do. GCC --help. Let me try that one. What is -o? Place the output into the file. Okay, yeah, that's your compiled version of the program where it puts it. This is maybe a little bit easier to use than the man page. That's why they put that in there. Here's the ls-help. See, I'm going up here. It's, kind of a shortened version of that. Versus, some cases it may be exactly the same. See here, goes in a little bit more detail, but maybe I don't want that much detail. Maybe I just want a shortened version. Set all that information. So again, I wouldn't say everyone does, but many of the utilities do. Now our path, where the system looks for the commands you run, and to see the current path, you do echo $, then path. So if I do echo, echo just displays the screen. $ path. Now when I'm trying to run a file, like I'm trying to run ls, it'll go through here and look for look through our path to see if it finds that that file anywhere, that executable file. Now I don't remember where it's at. I think it's under bin, but this is all the places it looks. This is there's very few viruses that happen on Linux. The GUI more probably, but one of the areas where they do have problems, and this is they talked about this in some of my security training, is that they'll create their own ls file and they'll put it someplace in your path. So instead of running the one that you should be running under, I think it's under bin. Let me go look. cd/bin. Yeah, there it is. Instead of running that one, it'll run the one under maybe oh, well, maybe it'll create one here, and maybe this will remove various items. Echo just deleted your files. Now there's a little bit more to it than this. But if because you have to actually, if I tried to run the ls at this point, if I did change mod 755 ls, if I did ls-l, you see how we have here is green. It's an application, I can run it. But if you just type ls, it defaults the one up above. If I do that one, see, it says just deleted your files. So again, there's a little bit more to it than just throwing a file in there. But the path tells you where to go look. Now if your path is screwed up, then it can't find your system files. So it's kind of important piece. Okay. In Pico, create a file called test.sh with the following line. And I already created this because I was testing this earlier, but well, I thought it was. Oh, it's what do I call it? Yeah, test. Oh, create a file called David. Thought I changed all those. Okay, David.sh. So come over here, David.sh. And all I did is I did an ls and then the greater than sign testing.doc. What this is going to do is going to take the output of the ls command and it'll redirect it into a file called testing.doc. Now after I did that, I did a change mod on it. So I can make it executable, so I can run it. If I do ls-l, you see I got, there it is, david.sh, see how it's green? And it's got executable commands. But if I try to run it, if I try to just type david.sh, and this always strikes me as kind of weird. See how it says command not found? Because it doesn't look in the current working directory. All it's doing is it's looking through your path for david.sh. And it says, hey, I can't find it anywhere. It's not under user games. It's under the bin. It's not under sbin. Now, instead, if I type this and then run it, that will look in our current working directory. I could also, remember, PWD shows where you're located at. I'm in the home user, If I do a /home/user/david.sh, put out the complete name, then press enter, it'll run it. But that shows you what the path does. And again, the dot / indicates the current working directory. Now let's temporarily add the working directory to path. So we're going to do path is equal to $path, colon, and then the dot. Let's see, hopefully I can remember that. Path is equal to path, colon, dot. Let me double check that, make sure I typed it all correctly. Okay. Now path we're setting here, and a $path will return this line right here, and then we'll do colon and then the dot for the current working directory. Now let me do an echo path, and you see at the end we have our colon and then we have our dot. Now if I run David .sh, see how it finds it? Because we added the working directory to that. If I type ls, see how it found the other one first? Because it goes, if I remember right, it goes in the order you see it listed here, and our working directory is at the end. So, like I said, it's a little bit more than just putting it into a directory. Let me play with it. Actually, I'm trying to remember now. Let's see. Path equals dot colon. I'll probably screw this up and not be able to run anything. Let's try that. Echo path. Has to be all uppercase. Okay, now let me type ls. See, I just broke my ls. By throwing the dot at the very beginning, that puts a working directory in that. Let me remove ls. Now if I do ls, it finds the correct one. So again, the order that you see here will control, which one does it find first. Now, standard input and standard output. Standard output is a place that a program can send information such as text. Standard input is a place that a program gets standard information from. Standard output might be your display. Standard input might be your keyboard. So you're having characters come in from your keyboard. Standard error is a place to send error messages. That seems weird, doesn't it? Standard error. Why wouldn't you not just want to send it to your screen? Well, there may not be anybody monitoring your screen. So now, device file. This resides in the Linux file structure, usually in the /dev directory. Remember, we looked at that before, and represents a device such as screen, printer, or disk drive. Note: do a who command to see the devices you're using. There. So I'm using TTY8 and PTS/0. Now, I'm not big enough into hardware to tell you what the TTY8 is. If I come over here, I know there's a lot of TTYs. So I'm assuming it's a specific hardware configuration. Okay. Now cat, this is an example to copy standard input to standard output. We're going to do a cat, and then we'll type whatever and press enter after each line. And let's see what it does. And you can do a Control D to exit out. Hello, Mom. Press enter. So I'm typing it in. That's my standard input, and then it's immediately sent it back out to the standard output. This is coming back to the screen. And once you're all done with that, you do a Control D. And that's a very boring example. It just shows you, as you type something in and press enter, then it sends it back out to the standard output. I don't think any time you'd ever actually want to do that. Let's see. Okay. Now redirecting. Instead of sending the results of a command to the screen, which doesn't make a whole lot of sense, you can redirect them to a file using this command. ls, and then greater than the file.txt. So if I do ls greater than the file.txt, then instead of throwing the ls to the screen, if I do cat the file.txt, this will show it. You see it put it to the file. Now instead, if I do ls greater than the file.txt, it won't overwrite the current file. A single greater than destroys whatever file's there. The greater than concatenates onto it. Actually, let me show something first. ls-l the file.txt. Notice the size of it, 329. Now let me do cat. Oops, wrong one. Oh well, I'll just do it. ls greater than the file.txt. Now I'm doing an up arrow to get to this. See how the size of it is now 658. So it didn't destroy it the first time. It destroyed it the first time I ran it. Then when I did the greater than, it concatenated on. So just add it on to the end of the file. Let's see. This will create a new file called the file.txt. You can append onto the existing one by using greater than. The greater than option is kind of a nice one if you're, especially if you have log files and you don't want to overwrite it each day. Now, if you want to use cat to create a file, and I don't think this is that great of a use of cat, but you can do that. If I say cat testing.txt, oops, type something wrong. Cat greater than, okay, greater than testing.txt. It is cold today. Hopefully tomorrow will be warmer. Now if I could do a Control D, now if I do a cat testing.txt, you see that everything I typed on the screen got put into the file. Well, very quick and dirty to create a file, but usually I just go in Pico if I'm going to create one. Now cat, this example uses the cat utility to concatenate multiple files, to put them into one file. So let me create file 1, file 2, and file 3. This is file 1. And I should know how to do a new in this, but I don't know how to do a new, so let me exit out there. And Pico file 2. This is file 2. Control O, Control X, Pico file 3. And I know it's some people say, well, it's easier to go ahead and just use one of those other ways to create a file. But I guess I like the feel of going into a utility to create the file. This is file 3. Okay, Control O, Control X. And to merge them, let's see, we got cat, and then the file names with spaces between them, and then greater than the merged file. So we'll come over here, we'll do cat, file 1, file 2, file 3, greater than merged file. That'll take the three of them and merge them into one file. Now that merged file can be called whatever you want, but you see how I put them into one. Now the neat part about Linux, in my view, is that you're not limited to how many options you can put here. There probably is a limit, but not a practical one where you'd ever run across it. You can put 20 files here if you want. Now, if you want to make sure you don't screw up a file by accident, then you can use the no clobber option. Let me look at test3.txt, see if I have it. Okay, I don't have it. So when I do the touch, it'll create it. So touch test3.txt. Now if I do ls-l test3.txt, you see we have the file. This next one, set-o no clobber. If I say set-o no clobber, doesn't actually come back and display anything. But now if I try to overwrite test3.txt in some manner. So if I do echo testing and try to overwrite test3.txt, it'll say cannot overwrite existing file. Doesn't mean you can't delete it first and then do that. So that's one option. I could do a remove test3.txt and then do my echo. I did the up arrow twice to get back up to that. Then press enter. And see, then it works fine. It's just kind of a safety feature. Let me grab a drink here. Now, having the minus before the O, make sure no file is overwritten. Putting the plus before it, make sure a file can be overwritten. Now you can overwrite no clobber in this manner. So if you know you want to destroy the file, but you don't want to actually do an RM before it, then you can do an echo testing, the greater than, and then the pipe symbol. So if I come over here, if I do an echo testing, then my the greater than, and then my pipe symbol, test3.txt, then it'll destroy what's there. Let me set my clobber back off. There we go. Now, redirecting a file can destroy it, and you have to be careful about it. Like if I do cat file 1, file 2, and then send it to file 1. Now remember what file 1 is. Looks like that. And remember what file 2 is. File 1, file 2, and then redirect it to file 1. Yeah, doesn't even let me to do that. What did I type wrong? I guess nothing. Input file is output file. What if it actually did anything? Oh, it did. It just gave me that. I was thinking his error message is giving me. It's just giving me a warning message. You see, file 1's is gone now, completely. What it should have done is we should have had file 1. This is file 1, and this is file 2 in that. Let me fix it. This is file 1. Just going in Pico. Control O to save it. Control X. What would be better is if you did cat file 1, file 2, put it into a temp directory, like a temp file, and then either do a CP or MV. So if I do a CP temp file 1 file, or CP temp file, and then file 1. Now if I look at file 1, that's what I wanted to do. So you have to be careful about that. Don't be afraid to use temp files on these. But before you put anything into production, you should be sitting there playing with dummy files anyway. Just make sure you got the commands right. Just like we're doing here. I mean, you go create a folder somewhere. You put some junk files in there, and make sure you got to know how these syntaxes work. Not everybody can sit there and remember exactly how it goes, and you don't want to find out the hard way. You destroy some production data. Now the /dev/null. This is a dead space, a file with nothing in it. Null, not a blank line or space. And you can just do a cat and then your dev null and then redirect it into testing.txt. Well, why use this? The file retains all of its original security, so you don't have to constantly reset it. Let's see, if I come over here, touch test4.txt. Okay, and let me change mod 755 test4.txt. Let me do an ls-l test4.txt. Okay. Now if I do an ls greater than test4.txt, now if I do an ls-l to show the I thought greater than overrode it completely. What one would override it completely? Cat, or echo maybe. Echo testing. Test4.txt. Yeah. Trying to think of some kind of utility that would destroy the permissions. Definitely RM would. So if you wanted to recreate the file and the utility you're using is destroying your permissions, then by doing this command it wouldn't. Can't come up with an example offhand, but now pipe. This connects standard output of one command to standard input of another command. Syntax: you got your command, then your arguments, and then your pipe symbol, and the command B in your arguments. We'll see some other examples, but one of them is if you do ls and then you do a pipe symbol and you send that into the sort utility. Let me see, sort dash help. Sort month sort. No, this is helpful. Trying to see something that oh well. What you can do is when you do the ls pipe symbol and sort, you can actually then write that to a file like that. So you're not limited to just piping the output of one utility into the input of another. You can actually then redirect it to a file. You can actually send it, not that I can think of an example, but you can send it to the sort, then you could send the results that to another utility, send it to sort again, I don't know. Then you can keep on redirecting it under, or not redirecting, but send an output of one into the input of another. Now that didn't do anything because those sorts were all the same, but you get the idea, I think. Let's see. And then this, it's saying here that using the pipe symbol is the same as sending your output to a temporary file. That's what the greater than does. And then the less than redirects that file into your command. Now that's kind of a nice feature to use if you're going to create some shell scripts, because sometimes you'll have some options in a file that you'll redirect into a utility, and then RM of course removes it. The translate command. This is kind of a neat one. If I do TR and then ABC and then capital ABC, and then we'll do Control D when we're done. Let me show you what this does. TR ABC, capital ABC, and press enter. And what is this going to do? Now notice everywhere I have an A, lowercase a, lowercase b, or lowercase c, it'll change it to an uppercase. Let's see, Kathy has a cat. See how it changes all my A's and C's? Now it doesn't work the other way. I mean, if I put everything in uppercase to begin with, it doesn't like change it back to the lowercase. Control D. Now you don't have to do the same letter even. You could do X, Y's, or A, B, C, and then you change it to X, Y, Z. So Kathy has a cat. Does weird things, but it just translates it. Everywhere I had a lowercase c, I put an uppercase Z. Everywhere I had a lowercase a, I put an uppercase X. So you see how it does corresponding. This lowercase a gets replaced with this uppercase X. Okay, that's a translate. Now we're going to look at an example here. First we'll create a file, hellomom.txt. First create a file, okay. Okay, so Pico hello mom.txt. Hello mother and father. Life at Camp Granada is fine. If it stops raining, we will go swimming. Love, David. Okay. Create a file, save it. I did a Control O to save it, Control X to exit out. Okay. Now, this right here, if we do a cat hello mom, then this will send the output of it into this utility. So let's take a look at that. Cat hello mom.txt and then tr abc. And didn't I just create that file? Pico hello mom. I'm obviously typing something wrong. Pipe symbol. Cat hello mom.txt pipe symbol tr abc. Now I went through my file and it changed all of the lowercase a's to uppercase a's and all lowercase c's to uppercase c's. I don't think I had any b's there, did I? No, but it would have done those also. Now that's versus where you're redirecting it in like this. And just like always, you know, if I have this redirecting to that, I can write it out to a new file. So I could call this new hello mom.txt. Now if I look at new hello mom.txt, I see my changes are in there. That's just an example. The true power of these utilities is not each one individually, it's being able to combine them together effectively. And some of the Linux, Unix scripts I've looked at is just like pretty intense. You have to get pretty good at scripts, and I was never that good at scripts to come up with some of the clever things people think up. Here's some more examples. You can do ls and then pipe symbol more. I don't know if I got enough files where this will work, but there it goes. It throws up my first page, and then if I press space, it'll bring up more, and space again brings up my last ones. So the more is kind of a useful utility to. Otherwise, if you press ls, well, ls-l, you know, it scrolls by. You can't see everything, and then you have to sit up here and scroll to see everything. But if you do an ls-l pipe symbol more, comes up my first page. Then you do a space, look at the second page, and space, look at the third page. Doesn't do the colors, so that's kind of bad. But ls-sort, and again, this shows an example where you can do sort and then more. Now there's a T utility that sends output in two directions. For example, I have my hello mom.txt file. I can do a pipe it into a couple different options. Or if I can remember all that. Let's see, cat hello mom.txt T David David11.txt and grep a. And grep a. Double check all that. Okay, I think I got it typed in correctly. Now, in case you're wondering what the grep command does, is it looks for, well, you can probably guess. See how I found all the A's? So grep is a way you can search. And see, I have a david11.txt file. So again, the cat will accomplish two things. Redirected it to this file, and also send it into this utility. I'm not sure if I ever use the T command or T utility. To me, I like to keep things simple whenever I did scripts, and to me, this wasn't so simple for somebody to come along after the fact and see, well, what is this doing? Just like today, I hadn't taught this for a year and a half, and I'm sitting here, what exactly does this do? I didn't test this one before I started creating the video. You don't want that. You want somebody to come in, and if there's trouble with your script, you want them to be able to easily see what's going on. By trying to get too fancy with these shell scripts, then you can make it so that they're not quite sure what's going on, and that's not good. If it takes two lines, it's not going to run significantly longer. You're not saving that much space for this one. Now, if you have another one that maybe this is very intense, maybe this takes 30 minutes, then maybe this might make sense. But if you got something very simple like this, put it in two separate lines. Now, running a command in the background, the ampersand, I think is what that is, the and symbol at the end sends it to the background. You continue running other commands. If I do ls-r, that means recursive. Has to be capital R, and then a slash. Well, that's everything, every file on the system. Then this greater than is sending it to this file. Not quite sure if I need to do that, but I'll go ahead and do it anyway. Home user / big file.txt, and then the ampersand at the end. Now, if you do a PWD, if this is something besides user, then what was mine anyway? I think mine was user. Hopefully, yeah. But if it says something besides user, then you need to set it to whatever your PWD is when you do this example. Now, if I do enter, it'll come up with all. Oh, this is great. There it is. See the number 1 and 6215. Okay. It's off running. Now, FG moves the job in the reason why you want to do this, by the way, is you can continue running other commands now. Unfortunately, the error message will pop up. Foreground moves the job in the background to the foreground. Not sure why you'd want to do that very often, but see if this is still running. It's still running. I'm trying to remember the syntaxes. I think you have to do FG and then the number. See, it's gone off. Let's see, FG and then 1. And I don't think I actually killed it. Exit 2. Let's try that again. Okay. And then FG 1. Okay. Yeah, see, it's still running when I moved it to the foreground. Well, maybe it finished. Trying to see my file. I'm going to do the home user. Okay. ls big. I can't tell if it actually. I'm assuming it finished. We haven't talked about how to list the jobs yet, but we will shortly. Let's take a look at this one. Run Pico, and then do a Control Z, then do a FG to move it back into the foreground. Sometimes I'm in here, and by accident, I'll do a Control Z. And they will tell you, use FG to return the nano. This is if you wanted to switch out real quick to do a command. They put that feature in there. But if I press FG now, I don't think you have to put the number 1. If you just press that, it'll take you back. And I could be typing whatever, and then Control Z, and do LS, do FG, and takes you back here. So again, it throws that command into the background, and when you do an FG, it throws it into the foreground. Say, hey, let's continue running this. Let's see, Control Z. Let me try doing FG1. Yep. Okay. You don't have to put it though. And Control X. Save it. No. Okay. Now processes. We got our PS. Let's take a look at that. I don't know if I have anything significant here. It doesn't look like it. This just refers to the shell we're running. PS. That refers to our process here. I never have understood that, because at the point where we're running it, it shows it's running. That seems like backwards, but it seems like when I'm returning here, it's no longer running, so they shouldn't show the current command. But it does. And it shows the time and so forth. Jobs. If I come here, it'll show our jobs that are running, like that. 1. Let me find it. There it is. I type jobs. That should allow me to. No, that's killing it off, isn't it? It's doing an exit every time I do that. Huh. Oh well. Let's go in Pico, do a Control Z, and do a jobs. See, and it shows what jobs we have running and the number associated with it. Well, the reason why that would be handy is this is how you kill a process. I can never remember this syntax. That percent always throws me. Look it up. So kill %1. And now if I do FG, see, Pico isn't running anymore. So if you have a job running, you want to stop it like that, then you can do that. Yeah, I just did that. Okay. Wildcards. Now these I just had to play with sometimes, so some of them I remember, some of them I don't. The question mark matches one character wildcard wise. I don't remember that very often. If I do ls phone, then question mark shows me that. If I do ls phone, see, I just returns me the phone there. Let's see. Echo, hello, mom. Phone, oops. Phone 3. Okay, now I do ls phone, then the question mark shows me that. If I do ls ph question mark like that, so it just matched one character. When I got phone 2 and phone 3, if I do the question mark, it will bring up phone 2 and phone 3. If I do ls question mark phone 2, see how it finds phone 2. That's what that does. Now the the asterisk, if I do phone, then asterisk, well, that'll show everything. And that's a good example. Let me do this one. See, I did LSPH. Even though phone and phone 2 and phone 3 had different number of characters, it gave me everything that started with PH. Now let me try this. This is the part I always have to play with. See what that gives us. Okay, everything ends with 3. ls asterisk dot doc shows me everything ends with .doc. I like asterisk pretty well for a wildcard. Sometimes I had to play with it to get it to work how I want, return correct information. The reason I like it is because it ties directly to DOS on Windows. And matches any number of characters, wildcard wise, examples. I think I've showed those by that. Now the bracket here. This matches any letter inside. Example, we create 3 files, cat1, cat2, and cat3, and cat4. And let's take a look at this. Touch cat1.txt, touch cat2.txt, touch cat3.txt, touch cat4.txt. And then we're going to do an ls cat, and then our brackets and 1-3 inside there. So ls cat 1-3.txt. See how it returns cat1, cat2, and cat3. You can do cat1-2.txt, or return cat1, cat2, or cat12.txt, and I return it. So you can have any kind of combinations here, for like that. It works with single characters, how we're using it there. And then this shows just how you do it with 2 characters here. See how we have a bracket, then a 1, 2, and then okay, had to remember. I don't use brackets a whole lot. Now this will return. Actually, let's look at this. So I'm not quite sure what this will do, to be honest. Touch cat11.txt 1, 2. There we go. And what's the other one? cat22. Oh, touch cat22.txt. I think what it'll do is when I do ls cat12.txt, I think this will return both of them. Anything that starts with 1 and 2. But let's see. No, I was wrong. Probably have to have an asterisk here. Let's see. Not quite what I was wanting, but closer. But let's try cat12 and then cat12.txt. Now this will look for anything single character wise for the 1 and 2. And then next character has to be either 1 or 2. Now if I change that and change this to just 2 like that, then that should just return cat22. Or I'm wrong. Oh wait, the other one has 2 also, doesn't it? Never mind. I was lying to you. Put 1 here and 2 there. See how it just returns that first one then? Because it has to start with the number 1, and then it can be 1 or 2. Now I put this here just to show you, but truthfully, how you do that is you wouldn't put that. If you just have 1 character, you just put 1 there, like that. Now the caret or the exclamation. If I do ls and then our asterisk and then the caret, this matches file names that do not end with the letters A or B. So this indicates a not. And the asterisk is our wildcard saying everything. So it's everything that does not end with A or B. Down here, this is matches file names that do not begin with the B, C, or D. Okay, caret B through D. So it is alphabetically. Now, this would not include capital C. I'm guessing that would not be between B and D because it has to be the lowercase. So, anyway, you can use the caret or the exclamation for that. So caret is probably the best one to use. And that's the end of that lesson.